I don't know anyone who doesn't love walking on the beach, getting your feet in the sand, getting your feet wet in the salty seawater, and also just cruising along and picking up on all those little bits and bobs that you find washed out by the sea. So we're going to take a walk along the beach here between the dune and between the breaking waves and try and figure out everything that we find here along this beach zone. What you really want to look for is that tide line. The tide line is where the waves are pushing everything up into a particular mark, and usually there's one like along the lower tide, and there'll be another line along the higher tide mark, and this tide line is just a treasure trove of all the little things that get pushed out from the sea. Generally, these things were either floating out in the open ocean and the winds blew them close to the waves pushed them up the beach, or they were part of the reef and they were predated or big wave action dislodged them and they ended up getting pushed up by the waves onto the beach. But you can get such a great idea of exactly what the water looks like behind the waves or beneath the waves without snorkeling. You can see, is there a reef there? What's it made of? Is it really healthy? Is it full of life? Etc., etc. So it's a wonderful way to explore the ocean without actually going into the ocean. One of the highlights is, of course, finding seashells and gastropods along this little shoreline. And in my hand here, I just collected a little pile of things. So we have barnacles here on the top that were once attached to some rocks, obviously. This is coral, and that's the calcium carbonate skeleton that coral creates underneath it. These are limpets. Limpets all suck themselves quite firmly onto the rocks. There's a keyhole limpet where the siphon comes out the top. These ones are top shells or periwinkles. And this is a worm that has deposited this little shell around it, so calcium carbonate skeleton deposited by a polychaete worm. These ones are bivalves. You'll be familiar with clams and mussels and so on. And this one in the middle here, the bigger one, is a whelk. And whelks are well known as being some of the more ornamental shells that you might be familiar with. So we all have collected shells in our time, no doubt, but they all do serve a purpose in the environment. If you leave them behind, they can be reused by hermit crabs, or those nutrients just get worked back into the system and it all can be reused. So it is nice to just leave them where they are. Now, these ornamental types of whelks, obviously these ones are a little bit worn down. They're beautiful, it comes in all shapes and sizes. And when they're alive, it's a sea snail, really. It's a snail type of animal. And this one seems like it's been predated with that big puncture in the top of that hard shell. So something that could have predated this one is a mantis shrimp. And a mantis shrimp has this hammer-like front appendage that can blow a hole in these shells the force of a .22 caliber bullet. So quite amazing, and that's not necessarily what happened here, but that could have been what happened. So those were all discarded skeletons of once living animals, and you can also see living animals that are underneath the sand, or signs of living animals that were underneath the sand. So in the sand you see often all these little holes, hundreds or thousands of these holes, and they are all burrows of sand-dwelling animals. And all of the animals that live in the sand, that burrowing action actually is working the sand up from deeper levels to shallow levels, turning it over, and then they're all in their feeding habits ultimately cleaning the sand as well. So those sand animals are so important in keeping the sand healthy. You could have sand prawns like these ones that are burrowing down, and they're eating phytoplankton, so keeping those algae levels in check. And you also have animals like ghost crabs like here, and ghost crabs are eating all the detritus that ends up washing up on the beach, so all keeping that sand nice and clean and healthy. These are all from echinoderms, which are the pentamic symmetry of sea stars and sea cucumbers, and these all came from urchins. So the sand dollar or sea pansy came from a type of urchin, that little green one that's so pretty, that's also from a bigger urchin. And then this spine is also from a nice big urchin, probably the types of ones you'll be familiar with that you really try and avoid standing on in the rock pools. They make lovely little skeletons that they leave behind all over the beaches. So you'll see sponges often in the rock pools and out at sea as well, and they often don't look like they are made of much. But if you have a look at the skeletons that wash up on the beach, you can see that lovely, intricate, delicate nature of their skeleton, made of spicules and sponge and protein. And they do that fantastic job of absorbing water through their channels, pulling it in through the channels and pushing it out through other channels. And in the process, they're filtering 1,000 liters a day per kilogram of sponge tissue of water, cleaning the water through them. And the skeletons are these very, very fine and delicate ornaments as well. So often the wave action is what's breaking things off from the reef itself. And in this case, we've got some blue coral worm, and the worms are depositing this calcium carbonate skeleton around them, and they can make significant contribution to the structure of the reef. Inches of the reef could be made from these coral worms. And when they get dislodged or broken off and end up on the shore, the wave action breaks them down, breaks them down, breaks them down. They are a significant contribution to the composition of the beach sand. Everything on the beach sand is made from the rocks or the animals that live on the rocks, and these contribute quite a lot to it. Another surprising contributor to the sand is these seaweeds. So we have a red seaweed and green seaweed here in my hand, and they have a calcareous skeleton, which is amazing to think of an algae or a seaweed having a skeleton basically. So after they die, this little skeleton will break up and become part of the sand composition over the next weeks or months. But when they're alive, they really do a fantastic job of keeping that reef rubble together, or loose pebbles and whatever substrate there is. They keep that really well together. And when they die, they contribute a lot to the sand. These ones all look like seaweeds, but in fact, they're all quite unrelated. This little group here are all seaweeds, and they all get put into groups according to their pigment, so green, red, and brown seaweeds. But this one here is a hydroid, so it's not related to seaweeds at all. It's in fact more related to corals and anemones. This is an actual coral. It's a Gorgonian sea fan type of coral. They deposit these beautiful skeletons in this shape because they like to sit in high, strong current areas in the deep water. And this is a bryozoan or moss animal. And anyone who's ever written a guidebook has had that awkward moment of where to place them. The taxonomists probably hate them or love them. And those bryozoan moss animals are totally unrelated to everything else in the picture, although these all superficially look the same, a bit like plants. Now, sometimes you find these golf ball sized blobs. Occasionally these golf ball sized blobs are just charcoal from someone's barbecue, but in this case we're looking at sea squirts, which are tunicates or ascidians, and they're chordates, which are more related to you and me than everything else that we've looked at, because in the vertebral or in the larval stage, they have this notochord, which is the precursor to a vertebra that you and I have. So there we go, sea squirts or tunicates. And sometimes when you're walking along, you see these jelly-like blobs. Now, of course, jellyfish sting, so you shouldn't pick them up, but you probably can't help yourselves like me. And they could be one of three things. These jelly-like blobs are either Scyphozoa, which are your conventional stinging jellyfish, small and large, and you do get some colorful ones as well as the clear ones. They could also be ctenophore jellies, which don't have stinging cells, but they rather produce a slime. So if you picked up one of those, it'd probably be a little bit more slimy. And the last thing that it could be, if it's a clear jelly-like blob, is a salp. And the salps are also tunicates, which are chordates, just like the sea squirt, and more closely related to you and me. So it is worth taking a closer little look at these clear jelly-like blobs that you sometimes find. Other clear things we find on the beach are these glass pebbles left over from people who have discarded their glass bottles. They end up getting broken up into smaller fragments and creating these lovely pebbles. They you can collect and you can create some really nice ornaments or mosaics in your house from the glass pebbles. And now we're going to look at this Portuguese man of war or blue bottle, and they're all members of what's sometimes called the blue armada. So it's a whole lot of animals that are floating out in the deep ocean currents. They don't really want to end up washed up shore on the beach where they're going to desiccate and die. They want to stay out in the open ocean, floating in the currents as plankton. But sometimes if you get a couple of days in a row of one really strong wind in the same direction, a whole lot of these types of animals end up washing up on the beach. So if you see one, you could see more. Now, the blue bottles are quite amazing. It's actually a colony of animals. One of those individuals is the float, the gas-filled float. Others are the hanging tentacles that feed. Others are tentacles that are more to do with reproduction. and they float around in the open ocean currents. But have a look how actually well camouflaged they would be, and they do look like a tiny little wavelet. That little sail makes this beautiful little wavelet looking structure that would perfectly camouflage them out there. But they also get left-handed and right-handed sails out of this float, and that will determine which way they blow when the wind pushes them. So ideally the prevailing winds will keep them pushed out to sea, but occasionally if you have multiple days of a strong wind, it ends up floating them onto the shore. So they are known for their nasty sting, but amongst these animals they get predated by turtles, certain fish like sunfish, and occasionally birds as well. If you see bluebottles, it is worthwhile looking out for other members of the blue armada, such as this one, by-the-wind sailor, or this one, raft hydroid. They're all hydroids and closely related to the corals and anemones in the group Cnidaria, so they have those cnidocyte stinging cells, and they all come ashore sometimes together, so it's worth looking out. If you find these guys, you might also find a purple sea snail or violet sea snail, and these actually eat the raft hydroids and the by-the-wind sailors, and they deposit this mucus gas raft, and they also just floating out there in the open ocean, not really wanting to end up washed up on the beaches, but very cool when you find them. And possibly the coolest animal in the ocean, in my opinion, are these sea swallows, or sea dragons, or blue angels, various names. And they're more closely related to the nudibranchs and the sea slugs. And they're living out there, just sitting themselves suspended on the surface, hoping not to break the surface tension by all these little appendages. Aren't they just absolutely magnificent? I only find these every couple of years, but when you see all the other blue things washing ashore, it's well worth looking out for them. These eat the other ones as well. They eat the raft hydroids and the blue bottles, and themselves are also eaten by fish, turtles, and some birds as well. So today, when you do a beach walk anywhere in the world, you will also invariably come across some plastic pollution, litter, and remains of things that we have left behind. This is obviously a flip-flop. We've done beach walks in the Indian Ocean on uninhabited islands where we found over 100 flip-flops in a short space of time in quite a small area. And in the Aldabra cleanup project, which is an uninhabited atoll in the Indian Ocean, they found more than 360,000 flip-flops. So it's a staggering amount. There is some little resorts and schools around there that are also making some wonderful mosaics out of all the bottle tops and flip-flops that they find. You also today get companies that make products out of upcycled plastics and ocean plastic, but it really is a staggering problem that we have out there today. These little tiny pellets are noodles. Noodles are the building block for all the other plastics. So these will get put into a mold and build and develop all the bigger plastics that you know of. Of course, the noodles sometimes end up on the beaches themselves if they get discarded accidentally. And you can just see how perfectly they resemble little eggs and how easy it would be for various animals to eat these noodles, and that is part of the problem. Also, bigger pieces of plastic end up breaking down into smaller and smaller and smaller pieces of plastic, which then get predated by various animals depending on the size of the plastic at the time and depending what it looks like. And you can see how it looks like so many of the animals we've already looked at so far. Another thing is that toxins tend to cling onto these plastics. So when the plastics get eaten by a ghost crab or whatever, those toxins also end up working their way up the food chain to higher and higher predators, including eventually you and me. So it all is a bigger part of the problem that needs to be addressed. So a beach walk today, you invariably will start picking up some of these plastics. The urge is there, and people all get involved in the journey of 1,000 squats, I sometimes say, picking up all these little pieces of plastic along the way. But eventually, all the beach cleaning you're going to do will lead to you changing your habits at home, which is really important as well to try and turn off the source. But all of that ultimately leads you to the sense that we do need systemic change. We need to address this, tackle this globally in the bigger picture. And so that's where the ultimate thing you can really do about it is to vote. Vote with your money for companies that are making change, vote for politics that are changing things, and try and create systemic change that way. Now, this was one of the final things I found on the beach walk today. So cool, a little oasis of life all on one little oyster shell. So on top, we have green and red algae that's holding the reef substrate together. Also little sponges that are cleaning out the water. Algae is also creating oxygen, and the sponges cleaning the water. And on the other side, we have barnacles and things that's also filtering out the water. So all of this on a discarded or a used oyster shell that obviously wedged itself somewhere in the reef. And it's just a reminder that nature will find a way, given the opportunity, and if we let it, nature will always thrive. And when it is thriving, it creates all these fantastic ecosystem services that you really can't put a price on, creating oxygen, binding the soil, creating the soil, cleaning the air, cleaning the water, and sequestering the carbon. So just a little reminder how important the services of nature are to us, and keeping it in its pristine state should be a #1 priority for all of us. So I hope this makes your next beach walk a lot more interesting, and thanks for sharing.